Today we're going to learn about similar figures and how we can use proportions to solve missing values within similar figures. Similar figures are just figures that have the same shape but are different sizes. So below, triangle ABC is similar to DEF. They are both right triangles, but they are different sizes. The ratio of corresponding sides within similar figures are congruent. By corresponding, I just mean matching. So if we take a look at this triangle, side AB corresponds or matches side DE because they are both the smallest lengths of the triangles. So I can write those as a ratio. AB corresponds to DE. Now I'm going to look at side AC corresponds to side DF because they are both the longest sides of the triangles. Again, because they're corresponding sides, I can write them as a ratio. We are comparing the two sides. So side BC corresponds, and we can compare to side EF on the small triangle. Now I'm going to plug some numbers in for each side so we can see exactly why they're similar. So if I look at side AB, AB is going to be 4, and that corresponds to 2 on my small triangle. If I simplify that, it simplifies down to 2 over 1. AC measures 8, and DF measures 4. If I simplify those down, I also get 2 over 1. And lastly, BC measures 6, while EF measures 3. If I simplify that, I also get 2 over 1. So when simplified, all of my ratios of each set of corresponding or matching sides are congruent. Each ratio all simplifies to 2 over 1, therefore, they are similar figures. Because corresponding sides in similar figures are equal, we can use proportions to find missing values within similar figures. So looking at the first one, I have two things that I'm going to be comparing. I have a small triangle and a big triangle. I'm going to go ahead and find a set of corresponding sides. So I have 4 corresponds to 14, so that's going to be my first ratio. That ratio of corresponding sides is going to be equal to the ratio of 7 and x. Now that I just have a proportion, I can cross multiply to solve. So 4 times x is 4x equals 14 times 7, which is 98. Divide both sides by 4, and we get x equals 24.5. Alright, for this next one with parallelograms, write a proportion and then solve for the missing variable x. Alright, so I'm going to compare my small parallelogram to my big. It does not matter which one you put first as long as your numbers are with the right shape size. So I see that x, my missing side, corresponds to 20 on the big parallelogram. 3 on the small parallelogram corresponds and matches with 8. Cross multiply, 8 times x is 8x. 20 times 3 is 60. Divide both sides by 8, and we get x equals 7.
0.5. All right, solve number 1 now, and then enter your answer into the computer. All right, let's check and see how you did. I'm going to first set up my proportion. I'm going to compare x to 6. Those are corresponding sides. I've decided to compare the big rectangle to the small rectangle. If you did it the opposite way, that's fine too. And then side 3 on the big rectangle compares to side 2 on the small rectangle. I'm going to cross multiply. 2 times x is 2x. 6 times 3 is 18. Divide by 2 on both sides, and we should get x equals 9. Go ahead right now and solve number 2. Alright, so number 2, just because it comes first, I'm going to compare the small triangle to the big triangle. First, I'm going to use x corresponds with 12.8 on the big rectangle or triangle. Then I'm going to choose to use 5 from the small, which corresponds to 16 on the big triangle. You could have also used, for your second ratio, 3 over 9.6. If you did, that's fine. You should still get the same answer. Cross multiply. 16 times x is 16x. We get 64. Divide both sides by 16. And you should get x equals 4.
Alright, solve for x for number 3. Alright, so this one was a little different because if you notice, my trapezoids are not facing the same way. One is flipped. So on my small trapezoid, 4.2 is the longer side, so that needs to match up with the longer side on the big trapezoid, which is 10.5. So then the smaller side of the trapezoid 2 matches up with x, the smaller side of the trapezoid. Cross multiply, 4.2x equals 10.5 times 2, which is 21. Divide by 4.2, and we get x equals 5. Great job if you were able to see that and match up your correct numbers. Make any corrections now before moving on.
So now we're going to go over what scale factor is. We've already dealt with scale factor, you just might not have known it. So a scale factor is just the ratio of any two corresponding lengths in any two similar figures. The word factor, it means what number are we going to increase or decrease all of the sides by. So let's look at the triangles here. I'm going to go ahead and write my ratio of my corresponding lengths. So I see that 10 on AB corresponds and matches the 5 on DE. We also have 24 corresponds to 12. I want to reduce or divide. So when I reduce, 10 over 5 divides down to 2 over 1. Similarly, the same thing happens with the other pair of corresponding sides. They reduce down to 2 over 1. 24 divided by 12 is 2. And again, these triangles are similar because the ratio of each of these corresponding sides are equal. So this gives us a scale factor of 2 to 1. So what this is saying that if I go from my small triangle to my big triangle, it increases by a factor of 2. So 5 times 2 gives me 10. The same way that 12 times 2 is 24. So again, a scale factor tells you how much bigger a similar figure is or how much smaller a similar figure is. If we were to go the opposite way, if I look at the big triangle and say 24 goes down to 12, or 24 decreases to 12 by dividing by 2. 12 is 1/2 of 24. So again, the scale factor is either going to be a scale factor of times 2 when going from small to big, or dividing by 2 when going from big to small. Alright, see if you can now figure out the scale factor between these two rectangles. So we can go ahead and write our corresponding ratios. So that would be 3 and 15, and 10 and 50. Now I can simplify this down to 1 over 5, and I can simplify this down to 1 over 5. So my scale factor can be considered 1/5, meaning that the small rectangle is 1/5 of the size, or we can consider also that the scale factor is 5. 10 times 5 equals 50. 3 times 5 equals 15. So when going from the small rectangle to the large rectangle, our scale factor is 5. If we go from the large rectangle down to the small, our scale factor is 1/5. It's just reverse, it's just that reciprocal.
For this last one, go ahead and find the scale factor between these two triangles. So this one was not as clear-cut as the ones before, and I can't automatically determine what factor or what number am I going to multiply by to go from one triangle to the other. So again, I'm still going to set up my ratio. So my side 20 corresponds to 8. 15 corresponds to 6. And 30 corresponds with 12. Now I can go ahead and simplify. Both 20 and 8 can be divided by 4 to get 5 over 2. 15 and 6 can both be divided by 3 to get 5 over 2. And 30 and 12 can both be divided by 6 to get 5 over 2. So my scale factor when I go from my small to my large triangle is 5 over 2. But if we do divide that out, 5 divided by 2 is 2.5. So the scale factor is 2.5. However, to get from the large triangle to the small triangle, my scale factor would be 2 over 5. And again, this is just the number, the factor, what you would multiply by to get from one triangle to the next. So 12 times 2.5 will give you 30. Opposite direction, 30 times 2/5 will give you 12. Ask a question before finishing up if you're confused.